Hello, welcome. Today let's try to solve another Leetcode problem. Recover binary search tree. So we are giving the root of a binary search tree where the values of exactly two nodes of the tree were swapped by mistake. Recover the tree without changing its structure. Yeah. So for example, the structure of the tree is like that. The root node is 1 and the left from the left side, yeah, it is the 3. And for the node 3, the right node is the right child is 2. Yeah, so the structure is like that. But because it is a binary search tree, we should know that, for example, for this one, at the left side, it should be smaller than 1, but it is not right. It means the 3 and 1 should be swapped to 1 and 3. Yeah. So for the right side, we know that 3 is the root, and from the left side, 1 is smaller than 3, it is the right. And also for the 2, 2 is bigger than 1 and smaller than 3. Yeah, so it means 3 and 1 need to swap. But how can we find that? Yeah, we should know the structure of the binary tree traversal. If it is in-order traversal, let me give you an example of the in-order traversal. Yeah, so for the in-order traversal, the numbers should always be ordered in increasing order. Yeah, let's check the numbers inside the tree. It should be, yeah, it should be different, but I think it doesn't matter. So the number of nodes in the tree is in the range 2 to 1000, and the node value is a very large number. And yeah, those numbers can be the same, like this 1 and 3, but it is a binary search tree. It means the numbers can always be unique. Yeah, we cannot have numbers like 2 and 2. Yeah, otherwise it cannot meet the conditions of a binary search tree. Yeah, let's check that. Just check the first example. So for this 1, 2, 3, if it is in order traversal, we should know that the numbers, the sequence of the node, if it is in order traversal, it would be 1, 2, and 3. Yeah. But for our tree, so for the in order traversal, first we're gonna check the left branch, and then the root, and then the right branch. For the left branch, we're gonna recursively check if it is in order traversal, the left, root, and right. So it is the 3, 2, and 1. So this is the in order traversal, 3, 2, and 1. Now we can check that. Yeah, because it is also said there are exactly 2 nodes of the tree were swapped by mistake. So it means there are only 2 nodes. We just need to find those 2 nodes. Yeah, and it is exactly 2. It means it can only be 2. Yeah. So how can we find? We just need to check this 1, 2, 3 with the in-order traversal of the numbers 2, 3, 2, and 1. So we find that 1 and 3 should be swapped. And how can we find that? Yeah, because basically inside it should be, if it is in order traversal, for the right sequence it should be 1, 2, 3. We just need to compare with another array with 3, 2, 1. How can we compare? Yeah, we just need to take use compare one by one. If it is not equal, we take it out. If this is not equal, we can take it out. So we are sure 1 and 3 should be swapped. Yeah. After that, we just need to use another in-order traversal. I will use another in-order traversal to check the values of each node. If this node is 1, yeah, let me put this, I'm gonna prepare another array, swap array. So the swap arrays inside it should be 1 and 3 because I'm sure not 1 and 3 should be swapped. So I will use another in-order traversal to check if the value is 1. Yeah, if the value is 1, if it is 1, I need to change the value to 3. Yeah. So if the value is 3, I just need to change it to 1. So after that, I just need to return the root because the structure of the tree cannot be changed. we can just change the value, put the values swapped, and the structure is still the same because the function will check the reference of each node. Yeah, after that we change the value. First of all, the function will check the reference, and then it will check the values inside the node, inside the reference. It will check one by one. So it means we can do it like this. First of all, we're gonna use the in-order traversal to get a sequence. So for example, we get a sequence of 3, 2, and 1. And then we're gonna compare with the right sequence 1, 2, 3. So after that, we find the swapped value, it is 1 and 3. After finding the swapped value 1 and 3, we just need to use another in-order traversal. Why I still use another in-order traversal? Because I just needed to copy the code. Because from here, basically I used in-order traversal, so I just copy the code, use another in-order traversal. You can also use other traversals like pre-order or post-order. It's the same. Yeah. So if the value is 1, if the value is inside my swapped, it is 1, I just change it to 3. If the value is 3, I change it to 1. Yeah. Now let's just code. Yeah, let me just write the code like this. So first of all, I'm gonna define an in-order traversal function. So it is in order. We're gonna use the DFS of in-order traversal. So let me put a node inside. So inside, I'm gonna give a node and a result. This result is just an array. So after all, I'm gonna call this in-order traversal. So inside, I'm gonna give a root and an empty array. So after that, my in-order traversal will return a result. So the result will be the sequence. For example, for this example, the sequence it will be like 3, 2, and 1. Yeah. Now let's just finish the in-order traversal. So in Leetcode, I think there are a lot of problems about in-order traversal. If you solve that problem, basically you can write the in-order traversal. So we need to check if there is a node. We're gonna use in-order not dot left, and then result should append the value of the node. After that, we're gonna in-order node dot right. So after this, we basically get an in-order array. Let me just print out the result to check what it is inside. Yeah, just check the in-order traversal if it is right. Invalid syntax. Yeah, because I have another return. I don't need a return. Let me just check this result. Yeah, because there's 2 values inside. I should have another result. Let me just give a result inside. Yeah, this result is just the array, the variable inside my in-order traversal. Now let's just check the values inside. So I printed out the result. It is 3, 2, 1. So it is as my expected. So but the actual result should be 1, 2, 3. So from this I can find which swap value. Yeah. Now I just need to prepare a swap array. So the swap array inside it will be 1 and 3. How can I find the values for the swap array? We just need to use a for loop. So for AB in I'm gonna use a zip result and sorted result. Yeah, so the sorted result is 1, 2, 3. My result is 3, 2, 1. So from this I can find 3 and 1. I'm gonna put 3 and 1 inside my swap. Yeah, I don't need to take care about the sequence because it doesn't matter. I just need to swap the 2 numbers. So I'm gonna put the 2 numbers inside my swap. Basically, it is 3 and 1. Yeah. Now let's check if A not equal to B. If the numbers not equal, I just need to put it inside my swap. So swap dot append this A. Yeah. So For example, first of all, the result it is a 3. 3 is not equal to 1. I'm gonna append the 3 inside. After that, I'm gonna append the 1 inside. Yeah. Now let's just check what's inside the swap array. Yeah, let's just check if it is 3 and 1. Here I'm gonna just print out the swap. Now let's check what's inside. Now you can see that inside of the swap array, it is exactly what we need. It is 3 and 1. Yeah, now we are sure that 3 and 1 should be swapped. What we need to do, we just need to use another inorder traversal. Let me just copy the code and change a little bit to make it work. Yeah, let's just make it inorder swap. Yeah, just to add something. Let me just copy this inorder swap, and here is also inorder swap. And now I don't need to return this result. Let me take out this result. Yeah, basically I'm gonna call this inorder swap function. So I'm gonna call this inorder swap, and inside it's gonna be the root. Yeah, after I call this inorder swap, I need to change the value, swap the value, like the 1 needed to change to 3, this 3 needed to change to 1. Yeah, so here I needed to do something in between this result.append not value. Yeah, so for here, I just needed to have a check. Yeah, let me just check this value. So I need a check. So if not.val equal to, let's say, the first value of swap, if it is equal to swap 0, what I need to do, so the not.value should equal to swap 1. Why? Yeah, because if I find a value, this is 3, I need to swap. How can I swap? So the not.value, I just need to change it to 1, so it equals to swap 1. So swap 1 should be equal to the value of 1. So in this way, it can be changed. Yeah. So similarly, I need another if check. So let me copy the code and put it inside. So I'm gonna use elif to check not.value equal to swap 1. So inside, I just needed to put it swap 0. So in this way, in between, the 1 and 3 should be swapped. I just swapped the values, but not the not. Yeah. Now, what I needed to do, I just needed to return this root, because the reference will always be the same. Now let me just run the code to check if it works. Yeah, as you can see, it works. Now let me just take out the print and submit to check if everything works as I expected. Yeah, so after deleting all those print, and I'm gonna submit and check if it works. Yeah, as you can see, it works. It is 72% of all Python 3 submissions. Now let's analyze a little bit about the time complexity. So we basically used the two DFS, two inorder traversal. So the time complexity is still ON. Yeah, and here we also used a for loop, but this is just O1 because inside this is just ON. This is another ON. Basically, it is a O3 times N. It is a big ON time. And for the space complexity, because we also used the space, we used a result array and also for the swap array. So the space complexity is also ON. Thank you for watching. See you next time.